Hi there, welcome to the data science project in Python, and we will see how you can create a time series model within this Python Jupyter notebook. So the very first question arises is, what is time series? So to show that, here is a quick snapshot of a time series. So what it has is basically a main and very important column is date, and then the number of births, and then the week, day, year, month, day of year, day of month, all of that column. But what I would really like you that don't just consider these columns for a moment. We will hide them, and these are the two columns on which we really need to focus for any time series related project. And there is always a chance that you can then, once you are pretty much aware about the basics, you can look at all of these columns, right? So I'll just press Ctrl C and it will be hidden. So what I want is, or the question which I was trying to explain you what is time series just in a nutshell is the data points, which is this, the number of births over a period of time. That means here the data is collected every day. That means it's a daily data. So this is the data points which are collected over a period of time, and the period of time is day. Similarly, if you have seen, there is the population data which government collects after every 5 years or 10 years based on the frequency that they have set. Or there are something which is called as GDP data, which is the number are coming out on a quarterly basis. And similarly with the company results, all of those data are over a period of time. And you will see in most of the projects that you will be doing is data is getting collected over a period of time, and that is one of the important stream within the data science project to know how you can calculate the time series forecasting. So in a nutshell, the answer I wanted to give you is that whenever the data is collected over a period of time, that is basically nothing but the time series, and for that you need to use the time series modeling approach for the for doing the data science project or for the forecasting of the future values. Alright, let's go back to the Python, the Jupyter notebook. So for that, what do we need is basically a couple of libraries, imports, pandas as PD. That is our basic library. I will show you the library requirement as and when it is arising, so that you will know why we are using a particular library. But two important libraries we always import is, one is for data reading and one is for data visualization. So import matplotlib as pyplot as plt, and magic command which is %matplotlib. If you don't know this particular module, it's nothing but the data visualization module, and what we are doing is using the as keyword as we are specifying the alias. So this is just to keep in mind that you are completely big enough, but if you already know, you can always skip this part. So after that, this magic command indicates that you want to visualize or you want to display the plots just below the command you are executing, otherwise it doesn't display, or you need to use the command like plt.show. So just to avoid one command, we are having this magic command which is %matplotlib inline. So let me execute this, and now it's just a warning that numpy and font size changed, binary compatibility, I think we are good. This is just a warning we can ignore. After that, we need to first of all read the data, and what do I have is basically the same birth file which I just showed you. So let me just add one more column and paste the link. So this is what I have is basically the total, the date and daily total female birth in California 1959. This is the data set you can even find in the description. Now with this, I would suggest that keep on viewing it, because we will continue seeing the even the interview questions and the scenarios, whenever you will see that, whenever I will figure it out that it is important from the perspective of interview or from the project crucial from the project point of view. So let me close this and let me read this data over here. So for that, what I will say is birth or f underscore birth, just to be very precise. This is the object we are creating, and pd.read underscore csv, and in the csv file what we can do is read, first of all, specify the file name. So in my case, the file name is this. This is the minimum what you need to do. So let's see what happens if we execute this. No error, no warning, we are good. F underscore birth, and let's explore the data. So what I am going to write is basically the head command which shows the first 5 observations. F underscore birth, bi. Okay, and this is the basically column date and daily total female number. That's the column that which you had just seen in another window, which I opened it over there. So, and the first, this column basically an index column by default created if we are not specifying the index. So indexing is very important from the perspective of that you want to further manipulate the data by looking at, let's say in this case, date. For example, you want to specify a couple of dates, or let's say 1959 or 1959-01, that means the January data. All of that slicing and dicing can easily happen if you specify the date column. So indexing is very important, which basically helps us in many ways to manipulate as well as get the desired operation done. So this is the basic, but if let's say we want to specify the index column as well as this is a date column, right now the date either can be parsed or not parsed, but just to make sure that date is parsed, that means Python or in this Jupyter notebook, when you perform date related operation or create an algorithm, the date should be properly parsed. So there are a couple of parameters that you can do. First of all, index underscore column. So index underscore call is nothing but specifying in which column you have you want to specify index. So just to view what are all the columns that are available, you can press shift and 2 times tab, and which basically shows all these different columns over here. And I just wanted to use the index underscore col if I'm not wrong. I am not able to see the column, but there is this column which is index. Yeah, there you go, index underscore column. You can specify header, you can specify separator. By default it's a comma separated file, but if you have any other separator you can specify this, and you can read this as well because it has a lot of parameters. It has explanation for each parameter, and I think down there it has some examples as well, looking at the file location and all. Okay, so index underscore call equals to 0. That means I want the first column as this, comma parse underscore date equals to 0. Let's see, date underscore parse or parse underscore date. Let me just quickly see what is the name of this. So parse underscore dates, DATES. So now we are good, and if you see, we have date over here and female births California over here. Now many times there is a question which you will usually find, that if you have a data frame like this, then how you will convert into a series. This is a data frame. So there are 2 ways in which you can convert this into a series. One is simply coming over here and saying squeeze equals to true. So now if you see, this is converted into a different format altogether, right? Earlier there were proper column and everything, but now if I look at the type of f underscore birth, why I'm writing it wrong, PIRTH, this is series, right? But if I don't have squeeze equals to true, if you see, this is a different format, which is a data frame. Now earlier it was series, but now if I execute, it's a data frame. So data frame and data series is basically 2 different objects. Series is something you need for the time series analysis, but generally what happens is, because there is a lot of data exploration and data manipulation that is needed, DataFrame, you're working on DataFrame is far more easier than working on series. Once you are done with working with the DataFrame, you can always take the series out using the value method. So series underscore value equals to specify f underscore birth dot values. So once you execute this, you can see over here series underscore value. If I execute, it's basically an array which the algorithm needs, and if I put a type over here, it is basically numpy nd array. So this values function basically helps us taking it out a series value, which is this, into an numpy array, which the algorithm usually picks up or needs to do the forecasting. So whenever the question comes like this, then you can always answer about the different types in which you can extract a series or create a series, and then how you can convert it into a data frame by using the values method. Alright, so this is done, but what else we can do is basically the size method I can show you just to indicate the size of the data frame f underscore birth dot size. So what it indicates that it has 366 observations, and if we look at the couple of last observations, so if you remember that head indicates the first few observations, but f underscore birth dot tail method is something where you will see the last couple of last information. And one thing very interesting which is coming over here is the total female births in California 1959. Clearly an outlier, right? Because if you see, for every date when these are couple of last observations, so this is somewhere around 55, 52, 48, and similarly for first few observations it was around anywhere between 30 to 44. So 1959 is clearly an outlier, and that's why you really need to see the first few observation and last few observation. And not only this, you have the method which is f underscore birth dot describe. So what it does, it describes or creates the statistic for the entire data set, which are very crucial. For example, count, that means you have 366 count. What is the mean? 47. What is the standard deviation? 100, which is very high if you look at the age perspective, and that is mainly because the maximum value is 1959, and that is definitely not correct. So to correct that, what we can do is we can write this command where we do not select the last row over here, where it is, yeah, over here. Alright, and let me just increase the size in case you are finding it a little difficult to view it. I'll go here, zoom. Yeah, I forgot to do it earlier, and I will just hide the header and I will hide the toolbar as well. Okay, now it will be much more clearer to you. So f underscore birth, again f underscore birth, right, from 0 to 365. Crap. F underscore birth. Alright, so now if I see f birth, again I'm writing it wrong, I don't know why, just that doesn't go with that. Describe. Now if you see, it's very meaningful. So the minimum value is 23. So minimum birth on a given day is 23, maximum birth on a given female birth is 73, and the standard deviation, one standard deviation is 7, and mean is 41. On an average, 41 birth, that female birth which is happening in the state of California. So a lot of important statistic, and company uses it for a lot of different ways in which they need to plan their future marketing. So without even forecasting, with this information, you can even figure out what strategy your company want. If you are, let's say, in a market where you want to see how much new production of, let's say, dolls or Barbie doll you need to do, or something which is related to the girls accessories, because those girls, with as and when they grow, their needs arises and they basically go out in a shop and do the purchasing. So with this, you can clearly understand how you need to plan your business. These are very economic factors that every company consider, like the minimum, maximum, standard deviation, all of this. And the most important is basically the average and standard deviation, because they reflects a lot that what is the average value and how much it can vary, or there will be a variability in the birth. So the next part after we have done this is just visualizing the data. So visualizing the data is very easy. f_birth dot plot, and because we have plot in line already specified earlier, here is a quick plot. So this plot basically indicates that yes, there is a variation in data. There you can see the peak, you can see the low point. So this indicates that there is a variation. There is a bit of a trend over here, but not a very specific trend. Looks to me a bit of a stationary series. So this basically, stationary is something you have heard it, or you must have heard it when you have looked at the data science project. And what it indicates is the series which does not have any trend factor in it, and it is like a constant series with the constant mean and standard deviation. So this is important. The stationary series is important when you are working with a time series problem, and the way we do that is to figure it out, basically the difference between the current term and the previous term, which we call it D. And I will show you in couple of minutes that what does this difference, order of difference, or the particular value D which I just mentioned. But before that, the way we can much more clearer see these trend or this series is by smoothing the series. Smoothing is one of the factors which you will hear, or you must have heard when working or reading about the time series project. So the smoothing is basically taking up these values and smoothing out with the help of moving averages. So moving average is nothing but the moving average is taking a specific value in count. So for example, if you are looking for a 5-day moving average, so you will start from the 6th day, and the first 5 value will be you will start from the 5th day, and first 5 value will be the average of first 5 value will be the moving average for the first data point. And how you can calculate over here is f_birth underscore mean or average is f_bi. Birth underscore mean equals to score birth dot birth dot rolling. Rolling is nothing but the rolling 5-day, rolling 6-day, rolling 7 days mean, what moving average value we want. So in that we need to specify the window parameter. So we can have 5, we can have 10, 15, 20. I have just taken the 20 and I'm taking the mean of it. Alright, so this is how the value will be captured over here. Rolling 20-day mean for a 365-day period. I think that is quite doable because we have 365 data point and we are just removing the first 19 data points. So f_birth dot plot, let me put it again over here, f_birth dot plot, f_birth mean dot plot, and if you plot it, you will see this is the value which you have got as part of the actual series, and this is how your moving average is. So it's clearly indicating that there is a spike over here somewhere around here, which is the later part of the year, and then it has come down, and a very small trend, if you see, little high trend which is clearly visible, which was not at all visible from here. That means the main series. So this way you can create the rolling 20-day average mean, and if I want, I can have like 10 days just for the experiment perspective, and you will see this is how the 10-day average mean. Or if somebody is interested in 30-day, you can just change the value of 30-day, experiment with it, and you can see this is how the 30-day. As you can see, there is a lot of variation, but one thing which is clearly visible is bit of a trend and the spike over here. So very useful and helpful feature, just to see the how you can remove all of this noise and see the clear graph. And this technique, a lot of time this technique is used within the stock market analysis. If you have seen the chart of any stock, this is how they look like, and the stock analysts use a lot of moving averages to basically remove all of the noise, because there is a lot of fluctuation every day in the stock prices. So they remove the fluctuation with the help of moving averages. So this is how you can basically do the moving average piece, and very useful because this even gets asked in a question about how you can smooth the series of a time series. Now there are many steps that are there for the time series analysis, and I will show you in as part of my next project about what are those, like normalization of the value, log transformation. There are other types of transformation that you can do on a project, but for this project I want to keep it very simple, and for that I will just straight ahead move to building a model, so that you are finding at the end of this video a confidence in you that yes, at least I can create the initial model, and with the upcoming video we will increase the complexity so that the learning is easy. Now what I want for you is to create a baseline model. So this is also generally the question within the interview, that what is a baseline model within the time series. So there are different types of models. One is a baseline model, I just said. There is a moving average model, there is an autoregressive model, there is an exponential model, and there is something which is called as ARIMA. There is ARIMA, which is seasonal ARIMA. So you will see that as you will gradually increase your understanding about the time series, there are a lot of models, like I just said, but baseline model is the model which is first of all very naive. That means very basic. Its assumption is that your previous value that you have, so right now, whatever day we are, let's say so today is 11th of November. So in 11th of November, let's say the birth number is somewhere around maybe 41, right? That means what we assume is tomorrow also we will get the number 41. So that is what we are basically assuming with the baseline model. So history, the recent history is the best reflection of the future. That's what the assumption is. And as you can see, it's very easy. Whatever your previous value is getting used in the next value. That's where you will create the baseline model. And to create this, it's very simple. So over here, let me start with. So earlier we already had the values, if I remember, over here, series underscore value, f birth underscore values, this statement. So with this series value, what we will do is we will create one more value which will take the next value from the existing data series. So if I show you in Excel, what does that mean is, so suppose this is date, this is particular date, for example this, and if we increase, let's say if this is what it is, then right now if it is 41, and tomorrow 45, and then 40, and then 38, then 41. Let's see, this is how our series is currently. So series t plus 1, what will be? So this 41 will come over here, 45 will come over here, 40 will come over here, right? So as you can see, this is how the values are coming. As I said, what we assume is the previous value is the best reflection of the future, and as you can clearly see, this is the actual value, this is the predicted value. Predicted value is nothing but the whatever our previous value were, we were taking it for the current value. So let me go back. So this is what we will going to do. So series underscore value we already had. So what I create is birth underscore df data frame and pd dot concat. Yeah, so concatenation function basically takes two series and create one data frame. So one series we already have, that is series underscore value, but we need to create one series which is taking one more value. So first of all, we have series underscore value, that is our current series, and then we have series dot values dot shift method, shift, shift by one place, right? So the Excel manual operation that we did it over here and surrounding it by, because this is part of one data frame, and axis equals to 1 because we wanted columns. If we execute this, all right, numpy array, and the array has no attribute as shift. All right, so what do we need over here is, so this shift is part of the pandas function or the pandas library. So what do we need is, first of all, the data frame f underscore birth, right? F series underscore value. So what I can do is I can just create something like value pd dot data frame. So pd dot data frame is nothing but it's a function part of the library which will convert a series into a data frame. That is what the requirement over here, because it's not part of numpy array. So what do we need is series value, right? Series underscore value. So now series value and everything, value over here. I will remove this value, and now everything is fine. So birth underscore df dot head, we have to give the headers to it, right? So birth underscore df dot columns, and within the columns, so equals to basically, and t plus 1 or whatever, current underscore birth, or something like actual birth, which is much more clearer, and forecast birth. That is it, right? Birth underscore df dot head, and this is what your value is. Actual birth, forecasted birth. So 35 is coming over here, 32 is coming over here, 30 is coming over here, because we have used the shift function over here. So this is one thing, one way of doing it. Another very straightforward way could have been using directly the f underscore birth over here. We already have this column. We would have just used this particular column dot shift, and that would have resulted into this particular metric. So that as part of exercise you can take, right? That from here we have converted the data series into a data frame and then use the shift function. However, we had the functionality available already because f underscore birth is already part of the data frame, and we could have directly used the shift function on this. So how you can do that? You need to show me by doing it, and I will put this particular Python notebook in my description, and then you can go ahead and directly use it, right? All right, so after this, once we have done this, is to identify the error that is present. So there are two ways to figure out the error. One is either you can figure it out on the complete data set, or you can have the train test. So in this case, train test really doesn't make any sense because this is a naive model. The previous value is being used on the current value. So I can show you both the approaches, but up to you how you want to decide. If the data set is small, like we have 365 observation, you can do it on entire data set. But if it is like 30,000, it's not advisable. You can just take a partial data by doing some sampling or directly taking it, and then go ahead and use it, the error. So how you can calculate the error. So how you can calculate the error is by importing the mean squared error module. So from sklearn.matrix import mean squared error. I have just pressed tab, mean squared error, and I need to import numpy as np because I want to take a square root of mean squared error, so that because mean squared error will going to do the square of the current value. That means if the mean value is 10, the square value will be 100. That is not interpretable, right? But if we take a square root, the square root of 100 will be 10, then the mean error will be 10. So 10 is nothing but your actual birth value. That means you have an error of 10 birth values which are present in the data set, which is nothing but a part of the variation. So that's why I'm importing the numpy as np. And to calculate the error, so birth underscore error equals to mean squared error and the actual birth value. So here it will be birth underscore df dot actual birth comma birth underscore df dot forecast birth. Now this will return an error, and the reason, if you see this data, the first value is not a number. That means the missing value. So if I just go ahead and execute it, contains NaN, right? So you need to remove this A over here. So birth underscore test equals to, take it from the 1 is nothing but this 1 till end. That is what I'm saying. So if I execute over here, birth underscore, sorry, I need to specify birth underscore test BIR birth underscore df. Yes, I'm fine now. And if I press B, which is creating this cell, what I want just to test it, birth underscore test dot head, and I have this proper value. So now if you see, it is coming here from 32 to 35, 30, 32, 30, 32. Okay, we have removed the first. So now this is basically our data set. So we will say birth underscore test, birth underscore test, and np.sqrt. So let me first show you the birth error itself, which is a mean squared error. So 10068 doesn't make sense, right? So what we'll do is np.sqrt birth underscore error, and that is 100. So again, doesn't make a lot of sense, because 100 is definitely too high. But this is something which you can say become a baseline model. And before I confirm on this, what I want is just to check the tail also. I want to make sure. Yeah, that's why I was thinking 1959 is coming, right? That's why 100 was not making sense for me. And because of this 1959, if you remember, the 100 was coming as part of the standard deviation, and that there also I said it's incorrect. So we need to remove this particular row. So once we have done this, so if you remember what we have done earlier in case of a data frame, when we had described it 0 to 365, right? So here birth underscore test, we have this 959, so we have to take till 364. So over here before this press A and birth underscore test equals to birth underscore test, and from here we will just take from 1 to 364. If we do that, A birth underscore test dot head. All right, so this has come from 2 and we have removed the first value. So what I need is basically from this has actually become 0 in the from the perspective of index. So 32, 35 and 30 and 32. Right now what we are getting is 30 and 32. So accidentally what we have done is remove this as well. Ideally what I should have done is 0 to 364, and to do that I just need to run this again. Birth df, tail is coming from here, and birth as this head. Now I'm fine. 32, 30, 34, and tail is over here. Yeah, so this particular observation, as you can see, is removed 50 to 55. And now if I come back here, see the birth error, which is 84. From 10,000 it has reduced to 84. If you can see, that's a significant improvement, and that is only because we have to make sure that we know what are the outliers that is present, right? And now if I take a square root, it's just 9.177. That means that is an error of 9, right? And if I go above and see the describe method over here, standard deviation is 7. So without even going to a model like this, with the help of standard deviation, from that also you can see that the variation is 7. But with this you can actually see, when you are using the naive model, what is the error. So 9.177 has become your baseline. That means this is such a basic technique, and with that technique we can get an error of 9 birth of every day. That means there may be a plus minus of 9 birth error that can happen in your prediction. So what does that reflect? This reflects that whatever advanced model you will going to produce, for example, if let's say you take exponential or moving average or autoregressive or the ARIMA, your model should always have the value which is below to this value. That means the error should go down as much as possible. So as I said, there are many models, but finally in any case we come down to something which is called ARIMA, right? ARIMA is nothing but auto-regressive integrated moving average. So what it does is it has basically 3 components. One is auto-regressive, right? Then you have integrated, and then you have moving average. I told you moving average is nothing but the smoothing part. How you smooth by removing the errors or noise from the data and see how good the value is. Autoregressive is nothing but what it assumes is the previous value is correlated, the current value is correlated with the previous value, and the previous value is the best reflection of the current value. So we see how well the values are related to each other. And integrated is nothing but the order of difference. So for example, like I said initially, that your series or your time series should be stationary, and to have the stationary time series, you need to perform some operation, and this is basically the this operation which it says integrated. So integrated is nothing but the parameter d, if I just mention. And to better understand this, what I can do is come to the Excel, or instead of opening a new Excel, let me open up the previous Excel file that we created. So what it does is basically figure out a difference. So for example, we are here, so this minus this, then it's a series like this, right? If let's say here you have 35. So with the help of this, what it tried to do is remove the error wherever it is present in the data set, and try to create it a series, the stationary series. That means there is a seasonal component, there is a trend component, all of that. It tries to remove that, and this is the order 1. So the value of d will be 1 in that case. So order equals to 1, that means d equals to 1, or d, and that's how you will specify its value. If you want the 2 order difference, that means d equals to 2, what you have is this: you are on second instance and going back to the first instance, and then you are just dragging it down, right? So this is d equals to 2. Similarly, you can have d equals to 3. So generally I have not seen going beyond to 2. Generally by 0 or 1 we are pretty much done. In some cases we can even go to 2, but I have never seen we are going to a level of 3. So 0, 1 or 2 is something you can experiment with it, right? So coming back to this autoregressive, like I said, you have a way by which you can identify its value. So it's a value of p, and moving average is nothing but the value of q. So autoregressive, for autoregressive and moving average, what we have is basically ACF and PACF curve, which is autocorrelation and partial autocorrelation, which checks from the current how well the current value is correlated with the previous value. And when we see the correlation is not present after the first value or second value, then we go ahead and use its value. So what I mean by that is, I am over here, I am creating one column over here, insert. So this value somehow will be correlated with this value will be correlated with this. If the correlation is present, that means this is the order of 1, we will not take it, because correlation basically creates a problem or try to influence it, and we just want a very normal model which can work on any scenario which it may face in the future. So we see that at level 1 there is a correlation present, so we move ahead. When we look at level 2, that means 40, checking 40 is correlated with 41, 38 is correlated with 45, that is p value equals to 2. That means on level 2, there is the correlation. If it is not present, we will take p equals to 2. If the correlation is present at level 2, we will not take it, and then we will move on to the third. So we'll check 38 with 41, 41 with 45, and generally at level 3, by level 3 you are pretty much there, and you would go ahead and use it. But that completely depends on the data set, about how your data set is distributed. We have seen even going to an order of 3 or 4 or 5 in this case. So let's go ahead and see this, how you can create the partial autocorrelation and autocorrelation chart. So for that I will press B to create a new line. So the package we will going to use is stats models dot graphics, right? And then the TSA plots import plot underscore ACF plot underscore PACF. Execute this. So I will say plot underscore ACF is to identify parameter Q. That means you have something like a model which we will be using is ARIMA P dq. So d value is somewhere around 0 because we have seen initially from the graph that it is a stationary. So pdq is this. Q value we will going to identify with the help of plot underscore ACF. So let's go ahead and see. So plot underscore ACF, and what was the name here? F underscore birth. F underscore, sorry, birth, wrong name. And here is our autocorrelation chart. So this is the 0, that means the current value. So what it has is the correlation between the actual values and the so here in this case, so let me go to the Excel just to explain this chart. So what is happening is we are at 0, that means over here we are having the actual value as 41 and predicted value as also 41, right? And this is, so this is what it is. And in this case, since you are you must be aware that correlation between 41 and 41 will be absolute, that means completely 1, and that's why that's what it is happening over here, right? So, and when we are going to a level 1, that means p equals to 1, the correlation between 45 and 41 is getting checked, and it says, because these are the critical limits, it clearly says that there is a correlation which is present at level 1. So at level 2 also, that means between 40 and 41, the correlation is present because it is above the critical limit. So 1, 2, and then on third it is under the critical limit. So what we can take is basically the first of all experiment with the p-value of 2 and then p-value of 3 and maximum by 4. So 2, 3, 4 is something what we can experiment with it and then check it, right? And similarly, what we have is plot underscore PSCF and F underscore birth, if I'm not wrong, yeah, F underscore birth. And here also after, so this is the first, this is the value that we have. The first value is out of critical limits and the second value is over here. So we can check with 2 and 3 in this case. So this is plot underscore ACF to identify the value of Q and plot underscore PACF to identify the value of P. Okay, so we'll start with the ARIMA model, which is P is 2, P and D is 0 because series is stationary. If you see this particular, there is a very less evidence that there is a sort of a trend or a seasonality that is present, and we will go ahead and create a model with the help of this too. And the Q value is over here with the correlation chart. We can start with the 1, 2, 3. We can start with 2, 3 and 4 and check it. So say P equals to 2 or 3 and then D equals to 0 and finally Q equals to 1, 2. So 2, 3 or 4. Ideally 2 we should not consider, so maybe 3 or 4. So let's go ahead and create the birth. So before we create the model, what I would like to do is, as part of the exercise, always create the train and test data. So birth dot f underscore birth dot size is 365. So what do we do is birth underscore train is birth underscore train, and that is 0 to, let's say, 330, and birth underscore test, sorry, f underscore birth, birth, f underscore birth 330 to 365. All right, execute. Crap, birth. Okay, so just to check, birth underscore train dot size 330, birth underscore test dot size is 35. So 330 and 35 is 365. So we are covering the entire data set. Now from stats models dot tsa time series analysis dot ar underscore model import, guess it should be not AR, that is only ARIMA, sorry, the AR autoregressive, but we want is ARIMA. Import ARIMA, execute this and say birth underscore model equals to ARIMA. In ARIMA we need to specify birth underscore train comma order equals to, so we may say 2 comma 0 comma 3. Okay, so inferred frequency, because we have not frequency distribution, 0 is not specified, that's why it is saying, not a problem. Birth underscore model underscore fit equals to birth underscore model. Once we fit this, we say fit, we need to fit the model. Okay, there is some error. The computer initial error coefficient are not stationary. You should induce stationary, choose a different model order, or you can pass your own state. So saying stationary, it is not stationary, so maybe we can say just 1 in this case. Execute this and now it is executing. So it was saying there is some sort of a trend which was present. I was thinking that from the visual that there is a bit of a trend but not very specific, but saying that we need to use the one parameter. So this is something we have got so far. We have fit the model, and there is this one statistic, birth underscore model underscore fit dot AIC, archaic information criteria. So this statistics basically indicates a particular value, and in general you can read about the archaic information criteria, that's a separate topic itself, but lesser the value of AIC, that means when you experiment with the order, right, let's say 111, 113, 213, 211, 212, all of that, experiment, if you do, you will see that the AIC value, whenever it is less, that's the model you need to choose basically, and that means smaller is better. Now let's go ahead and do some forecast. Birth model fit dot forecast step equals to 35, and we want the one. So it forecast gives a lot of different values, but we want just the first part of it by specifying 0, because that what contains the forecast values. So let's go ahead and execute steps, maybe, yeah, steps. All right, so now if I want to see birth underscore forecast, this is how your birth underscore forecast looks like. And if I see the test value, birth underscore test, this is how your test values basically looks like. These will be your 35 values. So what we forecast is 45, but actually we had 51. What we forecast is 46 and actual value is 46. That means very close. What we forecast is 43, actual value is 44, again very close. What we forecast is 44, but the actual value is 52. So you can see that in some cases we are predicting really well, in some cases we are not predicting that good, and that is part of, this is just normal. I mean, that happens when you produce the model. Nothing is perfect, otherwise there is no point in doing all the experimenting, but with experiment you can always reduce the error. So now let's go ahead and try to see the error. So same method, np.sqrt mean squared error, and within that I think first is the actual value, that means birth underscore test and then birth underscore forecast. execute this. The value we got is 6.86, and it is better than our model. What we created is the naive model over here. So if I go up, yeah, this is here. There was an error of 9.177, but then we got the error of 6.86 birth every day. So we reduced to 3 births, and that means we are doing a better job in this case. Now, there are many things which can be done to further improve it. Either you can be satisfied with this because this is again a very low score. I mean, very good score. The low is better in this case because we are very near to what how much female birth is happening every day in California. But you can further improve it, and how you improve it is basically going to here, say 213. You may say 111. Like I said, 211, 213, or maybe 211, 212, all that different orders that you can specify. There is a way by which you can automate the entire order, but for now I'm not specifying this because I really want you to experiment one by one, so that the more you will repeat, the better you will become in doing all of this operation. And after that, once you specify, I would really like to see your comment that what you have done, and you can take it up as a challenge that how you can reduce this value to something which is 4. So maybe so that's a improvement of almost 3 points, because right now we have 6.8, which is almost 7. But if we can reduce to something 4 or 4.5, that would be really great, and I would really love to see what you have done to improve it. Other way of improving it, apart from what you have it over here, the specifying the order, other way of improving it by normalizing the data or standardizing the data or doing the data transformation. There are a couple of techniques which are there for data transformation, and I will share it with you in the next videos. But those techniques really help you to bring the value down. So there may be a scenario that it may bring down, but there may be a scenario it may not bring it down. But it's all part of experiment. As part of the data science, you are a data scientist, and the scientist, whether it's a data scientist or any other scientist, the scientist's job is to keep doing the experiment. It doesn't really matter that you are getting very good result or very bad result. It may happen that you may get the worst result and you feel like, oh, why did I do it? But that's not the case. You have to keep on experimenting. The more you experiment, the more you learn about it, and you will actually become the real data scientist, but not the one who just run the algorithm and it's done. So I would really like you to test all of these different techniques, like I just said. But once I explain you the data transformation, the standardization, the normalization, then you can apply all of those techniques, and that will be really helpful for you for bringing the better results. So that's about it. I would really love to see your comments about this tutorial. I would really like to see what you want to further learn from the tutorial perspective, and your comments and your likes give me the motivation to create more videos. So I really would love to see what you have to say, and I will meet you in the next project.